Hello, everyone, and welcome. Today, we're going to be taking a look at your first, we can call this a project of Turtle. It's not really a game, as you guys were hoping, that'll be the next video. But this video, we're going to be looking at how to create our own turtle. Yes, our own turtle that has its own methods. So we are going to be working with classes. So you thought classes would just be a one-time thing? No, they're not. Trust me. Okay, you're going to, in this unit and in the next, you're going to be seeing a lot of the things we talked about in basic Python put into practice. For loops you might have not seen, but you'll see them a lot. Functions, you saw them a bit, but you'll see them a lot more now in the form of methods. And if you remember what methods are, they're basically functions inside of a class. And classes you'll see a lot as well. Okay, so make sure you understand what's going on. This lesson will cover a lot, but I'll make sure to go through it step by step. So if you look here, I have commented code, and we're going to go through all of this. We're going to go over how to create our new type of turtle, how to make it create a square, how to make it create a circle, how to make it create a rectangle, and how to make it create a flower. Okay, so let's get started. But the first thing we need to discuss is that, as you can see, we're using inheritance. If you forgot what that is, basically what we're doing is we're inheriting all of the turtle's properties. So whenever we create a new shape turtle, so let's comment this out. Whenever we create a new shape turtle, now whenever we create a new instance of it, we can actually choose its pen color and its fill color. That's what we're trying to do. So let's take a look at how we do that. Okay, so as you can see, we have an init method right here. If you remember what init is, it's basically whenever we create a new instance, like right here, we take in some parameters like color and we do things with them. Usually we will do something like self.color equals color, and then we can use that attribute later in different methods. But remember that we have inherited all of the turtle's properties. So we can use self.penColor and change this turtle, the instance of the turtle we're using, we can change its pen color to a different, whatever color they choose. We chose red. And then we can also set our fill color to the same color. And then I also hide the turtle because I really don't like the arrow. So like right at the beginning when we instantiate our turtle, I hide it. And then this part, okay? This is the part that makes this tick, right? Because what we're doing is we're inheriting all of the turtle's properties in its init method, right? Whatever happens when it gets initialized, we do that, and then we do some extra stuff. That's basically what we're doing. The shape turtle is doing everything a turtle can do, but we're adding some extra functionality to it, and that's what like shape turtle is. It's a subclass. It's an improvement of the normal turtle class. Okay, now let's take a look at how to make a square. Okay, so as you can see, we have the square, and it's a method, of course, because right here we're calling t.square. We're calling a method for the shape turtle. So what we're trying to do, okay, think about this, right? If we want to create a square, we have to think about a little bit of geometry. Squares have the same length on all four sides. The same L, right? The L that we put in, it's going to be the same length on all four sides. Every time we draw, right? Whenever we like draw a line, we want to turn a certain amount depending on the angle, right, of that shape. And as we know from our basic geometry class, all squares have 90-degree angles, right? 90-degree angles means it's a sharp right turn, okay? 90 degrees. So every time we make a line, we can turn 90 degrees, and we can do that 4 times in order to fill our square. And that's what this logic is. So we want to first begin our fill, right? If you remember from the last video. And then for iron range 4, so 4 times we're going to draw a line, and we're going to turn 90 degrees, draw a line, turn 90 degrees, draw a line, turn 90 degrees, draw a line. And then the last turn 90 degrees we don't have to do, but we do it because we want to reset it to its original position as well. Okay, and then we end fill. Let's see this in action. We haven't seen anything in action so far. So let me actually run this. Oh, yes. I forgot the main loop. So watch closely. It's a bit fast, but watch closely exactly how it makes the square. It went like this. It turned 90 degrees. It went down. It turned 90 degrees. Went left, turned 90 degrees, and then went up. And then we ended the fill, meaning that whatever was within the lines became red as well. This is a square. Nice. Looks like it works. Okay. Let's go ahead and take a look at how to create this circle. And basically what these are is I just want to go to a different area of the canvas so that I can make more shapes and not have them overlap. Okay, so next thing we're making is a circle, right? And you might think, okay, this is just going to make a circle and we're done. The problem with this method is that it actually doesn't fill. It doesn't fill what the circle makes. It just makes a circle. So I want the circle to actually fill as well. What we have to do is in our shape turtle class, we have to override the method. And you might have learned of this in our previous videos, or you might have forgotten. But basically, we're redefining the existing circle method. And our shape turtle has this new circle method. So we begin fill, of course. And then what this does, okay, you honestly, these are one of the things you can copy because it's a bit complicated. But we're basically taking the shape turtle, right? And then we're calling the super, basically we're calling the original turtle's circle method on it. So whatever, I don't want to know what circle does, right? There's a lot of math behind it, you know, using arc radius and all of that, and using some like high school geometry math. Okay, so I don't want to go into that, but all we have to do is we have to take the original shape turtle, turtle method. That's what super is, if you remember. Super is basically taking the original turtle's circle method and we're calling it, and then we end fill. So all we're really doing is we're changing the circle method to fill. And if we run this, we should get a nice filled circle. Okay. Things get a bit complicated with rectangles and flowers, so let's look at those. Okay, so next up we got a rectangle. You might already notice, instead of one parameter, we have two parameters, length and width. Okay, so let's look up here. So, first, whenever we're drawing a shape, we need to think of its properties, okay? And you can research them up as well. The two major properties you want to think of is the length and the angle, okay? So, let's think about this. A rectangle has 490-degree angles. So, we can use the same, and it's four, right? Four sides. So, we can use the same logic where we turn 4 times. We use a for loop 4 times, and we turn 90 degrees 4 times. But the problem is that every second turn we have to change from length to width, because think about it like this, right? If you have a rectangle with length 150, we go to the right 150, we turn, and then we have to switch to the width 50, and then turn left, and then we have to also again switch back to the length and then switch back to the width. And the way I solve this is that I use the modulo operator, and since I have a counter right here, right? Oh, and this should probably be 1 through 5, right? Since I have a modulo operator, we're basically checking, is it even or odd, right? If it's even, then we will use the length. If it's odd, we will instead use the width. And this is how we alternate between length and width. Try to make sense of this. If you still don't understand, you can ask one of the tutors. But let's run this. It kind of overlaps. But you can see that we've made a rectangle, which is kind of nice. The last thing I'm going to take a look at is the flower. But before I do that, there are 3 things I want to show you. The first thing is that we're going to clear the board because the flower is decently big. We're going to change the speed to 0. Now you might be wondering, what does that mean? When we change the speed to 0, that means it's instantaneous, meaning that every shape is created instantly. The reason why this is important is because to make a flower, we're going to actually have to create a lot of smaller circles in order to create a flower. And it'll take a long time for us to create those circles, even at max speed. So instead, we're just going to say, okay, every circle is going to be created instantly so that the flower will be created in the same time as the rectangle. And you'll see what that looks like in a bit. Okay, so as you can see, we have 2 parameters. The first parameter represents the radius of each of the circles, and f_num represents the number of circles we are using to make the flower. So I think it's easier for you guys to see what it looks like. So let's go ahead and run without debugging. That's basically what my flower looks like. It doesn't look exactly as beautiful as a flower. There are better ways to make a flower, but I'm showing you a very simplistic way of making this. You can improve it if you want to, right? That could be one of your projects, and I'll talk about the challenge that you have to do later. And as you can see, I've also made a hole in the middle. But basically, if you saw, I was making a lot of circles, and I was rotating the turtle so that the circles were made. Like each of the 12 circles were rotated in a certain way to fill up a flower shape. In fact, I think 6 flowers is the ideal shape. So I'll show you what I mean by that. Let's run this. Yeah, this is the ideal shape, most likely, to make a turtle. Okay, so turn rate might be the most confusing thing. So what this is doing is we are using a circle, right? And if you remember, a circle has 360 degrees. We are using a circle and we are dividing it by the number of circles we have. We are basically, what we're doing is that we're splitting up the 360 degrees for each circle. So if you have 6 circles, each circle gets 60 degrees on that flower. If you have 36 circles, each circle only gets 10 degrees, right? And that's why you saw like the circle with 6 petals looking much better than the circle with 32 petals. Because at that point, it looks like a circle, because every single circle is giving only 10 degrees. That's like nothing, right? And then this part is pretty easy. Okay, don't worry about this. This is just some logic right here. I wanted to add a little bit of a hole in the middle. So if you don't have, it's just easier to explain like this. If you don't have this, and if you run without debugging. Sorry for you guys seeing that animation. As you can see, there is no hole. So what we're doing is we were just moving forward by a certain amount. Like if the radius was like 40, we would move forward 5 to make a little hole in the middle. And then this part's very easy. We begin a fill, draw a circle, we turn depending on the turn rate, and we end the fill. And then we also do that for however many circles we have, f_num. Okay, now this video was pretty long. Your challenge is to use the shape turtle class. You can't just use normal methods or functions. You must use a shape turtle class. You don't have to use all of the stuff that I've done, like rectangle, flower, circle. These are just demonstrating different concepts. But you must create at least 2 different simple shapes. So like an oval, right, with different parameters, a triangle, a semicircle, maybe even a pentagon, a trapezoid, stuff like that, right? Using your geometry knowledge. And 1 complex shape, okay, a star. Okay, I wouldn't even consider a pentagon to be that hard. But if you really don't know how to do this, then you can consider pentagon as your complex shape. A cube, a better flower. There are lots of different complex shapes you can do. And you might be wondering, a cube, how is that even possible? Well, there are actually ways to make realistic cubes, and that will take research. So I'm expecting you guys, if you don't understand how to do something, to do research, create some really cool shapes. Turtle is like a canvas, right? So you can create a lot of really cool shapes with your own type of turtle. I hope you enjoyed this video. I know this was long, but I wanted to go over this because, you know, this is like the first like legitimate application of classes that you've seen in a while. Maybe if you've done the text adventure game, that's another legitimate use. But this one, people like programmers would actually use this in order to create a better version of Turtle. And that's why classes are so helpful. Thanks for watching. I will see you in the next video, which will probably be longer, maybe broken up into 2 different videos.